Hey guys, Mr. Gucci here recording the second help video for your homework. The first one was on scientific notation. This one is all about significant figures. Now, once again, I could not get my auto randomizer worksheet to function for this homework, so I just gave you a traditional worksheet, which means I can't be working through your actual homework questions because those are your actual homework questions, okay? But what I can do is I just pulled up an old document, okay, an old homework, and I'm just going to work through that homework, all right? And just know that the process, is going to be the same, okay? So let's take a look at significant figures. Now, significant figures are how many numbers, how many of the digits in a number were actually measured out accurately versus what was rounded. Now, I had an old procedure that involved you converting numbers into scientific notation and then counting the number of digits in the coefficient, and that functions. That works great. Or you could use this other method that I came up with that I tested and works. Significant figures. If you have a large number, ignore the zeros at the end. Those are not significant. And everything that's left, those are the significant digits. If you have a small number, ignore all the zeros at the beginning. And that'll tell you how many significant figures you have. Scratching my leg. Or, third case, if you have some in-between number, if you have any number where there's a decimal point in the middle of it, all right, any number where there's a decimal point in the middle of it, everything is significant. All the numbers count. So let's take a look at an example, okay? Take a look at number 23 here. It's a large number, all right? So let's just ignore the zeros at the end of it. Let's ignore the zeros, okay? So if we ignore these zeros here, we are left with a number where only the 2 and 3 were actually measured. So we would say that this number right here has two significant figures. All right? It's still 23,000. It's not 23. It's not what I'm saying. What I'm saying is this. Perhaps this right here, perhaps this represents the population of some small town, all right? I don't know, some small town, Booger, Wyoming, okay? 23,000 people. But is it really 23,000 people? All right, is it really 23,000 people? No, it's probably not. All right, the population of Booger, Wyoming, or wherever it was that I just said, all right, it's not 23,000 people. It's probably like 23,472 or something like that. Like the number goes all the way to the end. But the person who gave us this value didn't give us all of those digits. They rounded, all right? They rounded away the ones place to a zero. They rounded away the sevenths place to a zero, or the tens place to a zero. They rounded away the hundredths place to a zero. They rounded away all that information and left us only with the fact that it was 23,000-ish, all right? They only left us the 2 and the 3. And those are the significant figures here. They only left us the 2 and the 3. Now, the reason why this matters is because when we're doing math in science class, all right, there's always a question of what do I round my answer to? All right, how the calculator spit out a really long chain of numbers. How many of these do I need to write down? Well, the number you write down is going to depend on what you plugged in. If you plugged in a value that only, like this one right here, where only 2 of the digits were actually measured and everything else was rounded, then your answer can only have 2 digits and you have to round away everything else. So if this was like, some population calculation or something, and you got like, I don't know, say how much money do all the people in the town make or something on average, and you got like 53 1,271,000, whatever. All right, you can only keep those first 2 digits. You can only keep the 15 million. Everything else has to be rounded. Okay, so that's the significance of significant figures. Let's look at another one. Okay, number 23 here. Again, these are from an old homework, so you won't see this on your sheet. Big number. So I'm going to ignore these numbers at the end here. Okay, I'm going to ignore these guys because as far as I know, these are all rounded. This person only gave us 4 actual digits that they measured, 4 sig figs. All right. Maybe this is the population of Vietnam. Okay. Now, is the population of Vietnam actually 87,430,000 exactly? No. People being born and dying all the time in Vietnam. All right. Like 87,400,000, and maybe it's 31,724. But like, as we're talking about this, a baby was born. So now it's like, 25, oops, someone passed away. That's so sad. Back to 4. Okay. Like, the numbers change. But that down there is the exact number. This is not what we got. Whoever gave us this number, they rounded away the 4, they rounded away the 2, they rounded away the 7, they rounded away that 1. They rounded away everything up to the 10,000th, or 10,000th place, all right? And they only left us with an 8, a 7, a 4, and a 3. And everything else was rounded by them. So there's only 4 significant figures. And 4 isn't bad, all right? Anything 3 or more is usually good enough for us. Now let's take a look at number 24. All right, 24 is a small number, and so we ignore all of the zeros at the beginning. So let's ignore all these zeros at the beginning, and so this right here would leave us with 3 significant figures. This person measured the 10,000 place, the 100,000 place, and the millions place. They measured those, but they didn't measure the 10 millions. They didn't measure the billions. They didn't measure the 10 billions. They didn't give us any of those things over here. We don't know what those are, okay? All we know is the 10,000ths, the 100,000ths, and the millions place. That's all we know. So 3 significant figures, okay? Cool. And then before you think, Mr. Gucci, that seems like it's weird there's only 3 sig figs. Yeah, scientific measurements are pretty precise, though. We're actually going to do a calculation where we calculate the thickness of a piece of aluminum foil to like really, 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 really accurately, like a millionth of a meter. And we'll do those calculations and we'll be very close, okay? Now, number 25, all right? If it's a big number, eliminate all the zeros at the end. If it's a small number, eliminate all the zeros at the beginning. We can't do that here, all right? It ends in a 2, so there is no zeros at the end here because it ends in a 2. And there's no zeros at the beginning because it starts in a 1. What do we have here? We have a number where every single value in here counts. The number here is actually 1,000,002. Maybe Jeff Bezos calculated how much money he made since this video freaking started, and he made exactly $1,002. So this would be 7 sig figs. All right, because it's actually 1,000,002. He measured the 1, he measured this, all right, which happened to be 0, that, and that. 7 significant figures because everything here was measured, all right? If it was estimated, you wouldn't put a 2 on the end. If he estimated it, then that would be a 0, and there'd be only 1 sig fig. But the fact that we see a 2 right here tells us that no, it's actually 1,000,002, all right? All right, and if that sounds weird to you, then I don't know. Didn't like Doctor Strange and Avengers say there are exactly 14,300,001? Like it ends in a 1, so he wasn't estimating. He was giving you like 8 significant figures. All right. Ooh, that's a good question. That's a good question. I'm gonna use that. Doctor Strange being extremely precise in his numbers. All right. So here we go. Let's take a look at number 27. How many sig figs are here? Okay, small number. Ignore the zeros at the beginning. So this person only gave us 2 sig figs. All right, 2 sig figs. Yeah, they measured the tenths and the hundredths place, or they measured the hundredths and the thousandths. They didn't measure the 10,000ths, 100,000ths, or millions. All right, so they only gave us 2 sig figs here. Large number, ignore the values at the beginning. So there's only 3 sig figs. Okay, maybe this is the cost of my car. It's about the cost of my car. Okay, but it didn't cost exactly $12,500. There's always like taxes and stuff, right? Like, what did I pay for my car in actuality? Before it's a used subcompact. Okay, so this is a reasonable price for a used subcompact. It was like $12,572.31. Okay, this would be 1, 2, 3, 4, 5, 6, 7 significant figures. Okay, 7 significant figures. But if I told you the exact price of my car, you'd think there was something wrong with me. Like, why do you know that? Like, you can't even measure your mom. You can't even remember your mom's telephone number? Why are you remembering the price of your car out to 7 sig figs? So I don't know it, okay? I know that it's about 12,500. Well, actually, that should be lower, yeah, all right, or it would round up, all right? So, so maybe the actual price of my car was $12,472.31 after tax and fees, but that's not what I told you. I rounded away this. I rounded away that. I rounded away the ones place and the tens place. All right, and that means that this gets rounded up. So I'm only giving you 3 digits worth of information. You don't know what this zero or that zero actually is because it was rounded. Okay. 143.55. Well, listen, there's no zeros at the beginning or end here, all right? In other words, the decimal is right in the middle. And so this is 5 significant figures, right? This is 5. I don't know, this is like the price of like your new Beats by Dre headphones with tax included, okay? You gave me the full value. You didn't just say like $140, or around more than 100. All right, you told me the actual price. You gave me every digit that you could, 5 significant figures. All right, now there's the situation here that I want to discuss. Okay, a situation that I want to discuss that I don't see given as an example. So I'm just going to change this worksheet right here. I'm just going to change this worksheet right here. Okay, cool. What about this one right here? All right, 501.000. How many significant figures does this value have? Now, you might think 3. You're like, oh, let's get rid of those numbers at the end. But wait a second. This decimal is in the middle, okay? You're only supposed to get rid of the zeros at the end of a big number, okay? Or at the beginning of a small number. What do you do with this situation where you have a decimal point in the middle of your number? If you have a decimal point in the middle of your number, then every single digit counts. 1, 2, 3, 4, 5, 6. And the easiest way to remember this is to understand why. Why would it be 6? Well, here's the reason why. The only reason this person would bother to write 501.000 is if it actually ended in those measurements. And that happens, guys. All right, we only have 10 numbers in our system. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Sometimes 0 is the number that a measurement ends on. So 3 significant figures would be if a person just wrote 501. Maybe this is the distance from my house to the Wawa in meters. I live really close. But like, what if I actually measured it from my house to the Wawa in meters? And what if I was sure? What if it wasn't just 500, but it was exact 501? What if it was like exact like 501.000? Like it fell exactly on the smallest line of the ruler. Well, those zeros count. I measured them. It just so happened that when I measured it, it ended in 0. So everything here is significant. Okay? So there you go, guys. That's how you do this, okay? If it's a big number, all right, ignore the zeros on the end. And that's how many significant figures you have. What's left? If it's a small number, ignore the zeros at the beginning, okay? And yeah, all right? And if you have a number with a decimal point in the middle, everything counts. Okay, there's one more sample problem I want to do. Okay, so let's take a look at this one up here. Let's say we got this problem right here, okay? 0.03400. It's a small number, so let's ignore the zeros at the beginning, okay? So we're going to ignore these guys, okay? So how many significant figures? 4. 4 significant figures. And the reason why this is 4 significant figures is the exact same thing as the one below, all right? The only reason why the person put these zeros at the end of a decimal number is because they actually measured it out, all right? If they didn't measure these out, they wouldn't put them there. That would just be 0.034, but they put them there, okay? Which means that when they took, I don't know, maybe this is the mass of a sample in grams, all right? Or kilograms, whatever, all right? Well, they measured it out. They measured the tenths, they measured the hundredths, they measured the thousandths, they measured the 10,000ths, and it happened to be 0. And they measured the 100,000ths, and it also happened to be 0. The only reason those zeros are at the end of a decimal is because they were measured. So they count. if the person didn't measure them, if they stopped measuring at the thousandths place right here, then they wouldn't have bothered putting those zeros in. So this is for significant figures. Okay, that's it, guys. Have a great day. I'm going to load up another homework video next. All right?